to direct government realities on the ground. Following this assessment, the President directed the activation of a national post-flood mitigation task force to coordinate all recovery, relief, and mitigation interventions. To ensure an effective and coordinated response, specialized subcommittees have been established, namely the Anti-Flood Task Force, which is now the Post-Flood Mitigation Committee,
Hello. Good afternoon.
Good afternoon, sir.
Can we start? We are 6 here. That means you guys are 5. So let's start, okay? What you do first is that please go to Google or go to Chrome. Then type in Tinkercad. Tinker is Tinker. Cad, CAD. Okay. You see log in. You see a logo with red, gold, blue. Red, gold, blue. You enter. So let me share my screen with you. So you see this.
Yes, sir.
You have seen this, right?
Yeah, yes, sir. I have the app on my laptop.
Nice one. Who else? So Tinkercad is a basic engineering tool. Okay, it's very dynamic. It can be used for basic. It's a sub resource. Okay, that falls under Autodesk. Okay, falls under Autodesk. Then we can use it to do 3D modeling. Okay, we can use it to write code blocks, write computer programs using it. We can also use it for simulation of electronic and electrical circuits. So as you are doing engineering drawing, okay, The engineering drawing we are doing is actually electrical engineering drawing. It is not mechanical, neither is it civil engineering drawing. Had it been civil engineering drawing, they would have been going to do this technical drawing thing. Okay, so we are going to focus our attention on simulation softwares. We are going to use a lot of simulation softwares, the different types of simulation softwares, to the extent that we can print electronic circuits. That's the goal. At the end of the day, we should be able to print an electronic circuit of our choice. Okay. So I'll guide you through a couple of simulation softwares, not only this one. We're only starting with Tinkercad because it's very basic. It's very basic. We'll venture into KiCad. After Tinkercad, we'll venture into KiCad. Then we'll go into Multisim. Okay, Multisim. Then we'll also go into AutoCAD. Okay, AutoCAD. I'll also teach you Logism. Okay. Then we'll also use every circuit, which is my favorite. Every circuit. You'll be able to use it for. Did I introduce you to every circuit the last time? Hello? Can I hear you, please?
We can hear you.
I asked a question, nobody is minding. I'm asking, did I introduce you to every circuit the last time? It's a mobile application on your phone.
No.
Okay.
No, sir. Oh, so I don't know.
Okay, so this is what we start with. So please, those who don't have Tinkercad, please start by going to Google or Chrome. Then you sign up. Okay, you sign up. So let me go back so that I will also start. Then you see how it is done. So I will just type in Tinkercad. Tinkercad. You see it has appeared. So Tinkercad. So log in Tinkercad. Because I'm a member already, I have an account with them. So it will lead me straight here. But if you do not have an account, so what to require of me is to create a circuit. Please, have you gotten to this level now? If you don't communicate, we can't have a successful lesson because this is practical. We need to all be on the same page.
Hello, sir. No.
So I'll wait
Hello,
for you
sir.
then. Yes.
So, I'm at the Tinkercad page.
Okay. So you sign up. You create a personal account.
Okay,
Yes,
so
sir.
I
Yes,
should
sir.
go.
Create a personal account. You don't need to download anything, okay? It is a web application.
Okay.
So just create an account. Create a personal account. and you sign in with your Google account.
Okay.
And just follow the procedures. You see that everything will become okay.
Okay.
Where is the lady? Can we proceed?
Yes, sir.
So I believe you are all on this page now.
Yes, sir.
Okay, nice. If you are all here, then we go to the top right corner. You see create. You click on create. So these are the three basic things you can do with Tinkercad. You create a 3D design like these boxes and whatever. You can do all this. You can do this with Tinkercad. That's the first one. Then the second is to construct electronic circuit or electric circuit using breadboard. Okay. Then the third is using code blocks. Okay, so you're going to go through them. We have this is the home page. Okay, you can go to the classes. So it depends on you. As in, you join a class. So when you join the class, you have a group discussion. Then you have designs that are already there. Okay, these are all there like that. These are simulations. See, these are breadboard. Then we have Arduino works. Okay, you see, we have this ones too. So that's it. Then we come to collections. See, so what you have created here, you keep them here. You understand? We come to tutorials. So you can create a tutorial design here and look at this. There are so many tutorials that are here. So you do a lesson. Then challenges. So you have to join a hub. Okay, have to join a hub in order to get a task to perform. Okay. So when you look at the gallery, look at that. See, so you can use it for a lot of things. So we can use Tinkercad for science project, even science project. You can use Tinkercad for. Okay, you can use Tinkercad for physics projects, biology projects. Yes, I'm telling you, chemistry. You can use Tinkercad for electronic, electricals, mechanical, motion. You can use Tinkercad for all these. Look at that. This, you see, You see, this civil. You see that. You see all this. We can use Tinkercad for all this. That's why we need to learn Tinkercad. We can use it for amazing stuff. You see, there are so many for aerodynamics, right? Okay, so that's a gallery. Then let's go to learn first. So what do you want to learn? So you search for tutorials here. So you type in, if you want to learn about 3D modeling, you type in 3D modeling. If you want to learn about circuits, want to learn about Arduinos, Raspberry Pis, you can still do that. All embedded systems, you can do that. Then we come to teachers. See. So you sign up for a course, okay? And you join a class with Tinkercad. Now look at that. See, for electronic simulations, mechanical simulation, look at that. So it's a very powerful tool, okay? So if it had been, I don't know if you ever witnessed some people taking this course, it would have been I think drawing and drawing of lines. I don't want it to be like this. Okay, I want it to be something very practical that you reap some benefits from even outside the classroom. Okay. Okay, so let's see the kind of resources we're having. So this is it. Tinkercad blocks. Project ideas, hands-on learning projects, design and make skills. Okay, so you design and make skills in badges. We have challenges as fun community design prompts. Then you go for help if you need help. Then you have Tinkercad classrooms. Okay, I mean you can see all of them. We have videos, tutorials, and what have you. So today being our first time, we are going to familiarize ourselves with some stuffs. Okay. Okay, so now we can come here. If you have new design, then your own design, okay, notification settings. So let's go to settings. So here that's more about yourself. I mean, putting in your information. So for me, this is my name. You see that? And it's a private account. Okay. Only visible to you and your moderators. Helps them know who is who in their class. So it's a personal account. Okay. Then what's the rule? I didn't select any rule. I can update it. So that means I've created an account here. Okay. So that's it. Then we go back here to account. So my design, have I designed anything? So if I design anything, I could have saved it here. All these are not my designs. No, they are not mine. These are people's designs. I've not designed anything. Neither have I saved anything here. Okay. So, I mean, you will explore more as we go on. So for today, we're going to create an electronic circuit. To create a new circuit or to create something new, you always have to say plus create, plus create. That means you're ready to create something new. So we click on that. So what you want to create, in what category is it in? What category is it in? Is it under modeling? That's 3D design. Is it under circuits? That's electrical circuits. Then is it under code blocks? Okay. So today we are coming to create something under electronic circuit. Since we are doing circuit theory, we are going to use the Tinkercad to simulate our circuits. Okay. So let's see. Is it I didn't teach you the Kirchhoff's law? We are going to use Tinkercad to verify Kirchhoff's law. Okay. But for today, after I have helped you to familiarize yourselves with the breadboard and how to construct circuit, the first circuit to construct will be related to Ohm's law, since we have talked about Ohm's law. Then we will also look at what do you call it? RLC, okay, inductance, resistance, inductance, capacitance circuit, or linear networks, and we see what happens with it. Okay, so if you are with me, let's now start. So you click on circuit. As soon as you click on circuit, let's see. You see that it will change quickly. It will change you and bring you to the page of circuits. So what circuit are we coming to construct? Is it electric circuit or electrical circuit? I'm trying to experiment with something I've never done, so wait and see. I'll pick up this and put it here. You see that? Then I pick up this and put it here. That's a resistor. You just pick and you click on it and then you move your mouse. Okay. If you are using this into a pad 2, then you move your finger on the pad, it will move. Then I pick a switch. This is a switch like this. I fix it. Then I pick a battery. I fix it here. Let me fix the battery here. Okay. So I can choose to write the names of the items. So push button. It's okay. This LED, there's no need for value. I can change the LED to blue. So let me change it to blue. I've changed the LED to blue. Then the resistor. The resistor, I must know the value of the resistor. So let me say 150 ohm. So 150. Then I'll come and select the kilo ohm. I'll change it to ohm. So 150 ohm. That's all. Then I can choose to call the name of the resistor as in R1. So the resistor becomes R1. Okay. R1, a value of 150 ohm. Then I place the cursor on the battery and click on it. You see, it has given me battery 9 volts. I don't need any other name for the battery, so that's okay. Then look at that. I'm coming to change this. Okay, so you see this rotate. I can use R to rotate, or I can use this symbol to rotate. So when I press on R, that's rotated. You see, it is rotating. I want it to be horizontal so that I'll join it. Now, there's a switch. I can connect a switch from here. If I click on it, see, straight, it will join here. Usually, the reason why I told you my first time is that I usually join this one using breadboard. I don't do it like this. Usually, it is breadboard I use. I forgot to tell you that the LED has polarity. This is a positive leg, it's called the anode, and this is a negative leg, it's called the cathode. So the connection is correct. So I'm connecting from the anode to the resistor, is joined. Then this battery, the positive is rather down. I need the positive to connect to the anode of the resistor of the LED. So I have to mirror. Okay. In mirroring, I press this sign. Okay. I can also use a symbol M to mirror. Okay. So you see it has mirrored. So you see the positive has come up and the negative is down. So let me connect this. When I come this way, I can press it this way, press it, and then it will start to curve. Then I'll fix it here, back like that. So it's joint. Then the negative, the other side, I'll bring it down. I click and then draw it down. Click and then to make a thing. Click and you can go this way too, or go that way. I can turn. Later you click it to change. You have the luxury to change direction. So I come this way. I click again. Then I come this way. But then you see when the red mark shows, it means you can. That's a joint. So I join it. Now I've made a circuit. Now what will I do? Let me simulate a circuit. This is an electrical circuit. This is an electrical circuit. So let's see. So simulate. This start simulation. That means start testing. So start simulation. Now, if I press on this, you see the LED is glowing. If I leave it to go off. So you click on this, the switch. See that it's glowing. But because you are students of circuit theory, you have to analyze everything you are doing here. Had it been that you were learning something like digital electronics, you don't need to analyze the circuitry. But because you learn circuit theory, you must be able to analyze the circuitry. Okay. So when you press this, you see that there's indication, exclamation on it. That sign is an indication that there's over voltage or over current. Of course, 9 volts is enough to burn this one. Nine volts. 9 volts is enough to burn this LED. But by virtue of the resistor being here, this resistor, excuse me, I'll call you, hello? Good afternoon, madam. I'm well on yourself. Yes, oh, not well. Hmm. I'll call you back, okay? Sure, thank you. Okay, so please, sorry for that. Let's continue. Now, this resistor, the value is 150 ohm. This tallies exactly with what we are learning from circuit theory. So I'm glad that I'm the same person who has been given this course to teach. It will help me to lay more emphasis on what we do with circuit theory. So seeing that this is 100 ohm resistor, 100 ohm resistor has the capacity to resist certain amount of current, but it cannot go beyond what the resistor permits it because it is a fixed resistor. So its resistance is fixed. It means that should the current be more, if I'm trying to make this one look like in the layman's mind, it's like a lot of people are standing in front of a door that has the ability to permit only one person to pass at a time. So if more people are standing in front of the door and forcing their way through, right? And then, so there'll be bottlenecking. That bottlenecking will cause the people stranded there to start producing heat. So this resistor becomes hot. They'll be struggling. If the struggle goes beyond what the door can bear, the door will collapse. You see, so let's do an experiment with this one. You'll see what will happen. Before you do anything, you have to stop the simulation. So I have to stop simulation. So I stop simulation. And let me reduce the resistance. That means that I'm trying to open space, or let me say, I'm trying to open space for more current to flow, because resistance is inversely proportional to current. So if the resistance becomes smaller, it is like sending a small boy to go and fight Iron Mike Tyson. In this case, the current is Iron Mike Tyson, and then the resistance is the small boy. So by reducing the resistance, let's see what will happen. So let me put 10 ohm, 10 ohm, and let's simulate it and see what will happen. Watch you. If I press the switch right now, look, the LED is bent. This is bent. You see, it's bent because now I've allowed large amount of current to pass through because the door was left open. The door resistance is only 10. It cannot resist. It allows full amount of people to come. So they come and arrest this one. Note, the resistor here is meant to protect the LED from burning. Now we have put in a weak person to protect this. What will happen? If you let a weak person protect you, you burn. So that's it. So let's see what happens. If you should take 10 kilo ohm, or let me say 100 kilo ohm. That is 100,000 ohm. Let me choose 100K. 100 kilo ohm. Look at what happened. And then let's simulate. You see, only small amount of current is flowing. So you see the LED is now dim. So it is for you as an electrical engineer or electronics engineer to know the right amount of current you want to allow in. Okay, you want to allow in so that it will give you the best result over here. You see, this principle works perfectly with every other field. If you go to mechanical engineering, the same thing. If you go to civil engineering, the same thing. Electrical, electronics, everywhere is the same principle. There must be a balance. What do you want? What is your budget? What can you sustain? You see, these are the questions. So if you're able to answer the questions correctly, you will know what to supply and what the load needs. Remember, we say that the load, the supply, the current that the supply produces is dependent on the load resistor. Okay, so now let's see. So out of several trials, and let's say calculations, those days they were not having simulation software. So everything is calculated. They calculate and calculate. So they realized that 150 ohm resistor is best to protect an LED. 150 ohm resistor. So let's test and see. This is still there's caution. There's caution on it. So if 150 ohm resistor is best to protect LED, what voltage is it protecting it against? If the voltage is too high or the current is too high, the LED will not be protected by 150 ohm. So we even have to still increase the resistance. So let's go to 250 and see. 250 ohm, and let's test and see. Still caution. Caution. That means that you should be cautious. This LED will not last, it will burn. So let's still increase. So let's go to 300 ohm. 300 ohm, and let's test and see. You see, this is optimal. You see, so the LED will not be heating up with 350 ohm. So now that you have seen this, you don't need to go and worry yourself again. You just go straight buy 350 ohm resistor, buy LED, buy a switch, and then your battery. You can now produce this system. You do without going to do buying them and testing them and do try and error and realize that, oh, this is not the best. If you were not having simulation software, you would have been using try and error methods. You could imagine how many LEDs would have burnt by now. You understand it? So that is why the simulation software is there to help us. So I will allow you to also construct this circuit. Or have you done it already? Hello?
Yes, sir, but sir, please, my own is not on. I don't know. I've turned the battery. I want to turn the battery, but I don't know how to turn the battery.
You have to mirror it. But in the first place, you have to disconnect the wires.
Okay.
So in order to disconnect the wires, you have to stop simulation first. You stop the simulation. Then you come and click on the wire. Now the wire has been selected. If the wire is selected, now you press delete. Okay, delete
Okay.
on. You see that?
Yes.
If you want to make it again, you can still go ahead and make it. You see, you click
So how do I turn the battery?
mirror. You select the battery. Okay, let me go back. If you want to, you can undo like this. Undo, there is gone. Now, let me take off the connector from the battery. Selected, then you delete. You delete. Now you select the battery. You see it has been selected.
Yes.
As it's selected, you press on mirror. This mirror. It will
Okay.
turn the direction, or you can press on M and to turn the direction for you. Hence, the positive has come down and the negative is gone up. By my own, because of my direction, I need to turn it again so that the positive be up and then the negative will come down. So I mirror again like this. You get it?
Yes, please.
So you start from here, then you click, it will select, come this way, but you click again, it will turn, right? Then I click again. I'm doing this so that you'll be familiar with the software.
Okay.
So I've done that. Then I come here. Okay, so please let's all do this one and see. So you see that as we have done this, We could have just done this and send it to the company in China. Then they will print it for us on the. We would have done this. Okay, well, after we've done this, we can still do the same thing with keycard. So from keycard, then we send it to print. As in, we'll now go to the PCB layout. We'll convert this one to PCB. So to give us the printed circuit board version. So when we have that version, we just contact the company in China and they'll print it for us straight at a small fee. You see? So we'll do it like that. And it will be fun. They will print it and bring it to us. You see? So you go ahead
Yes, sir.
and let's go ahead and see what will happen.
Please, my own is working now. Yeah. Hello, sir.
Yeah.
As I press on the simulation and the light on by itself, but I thought we have to use the switch in controlling the light.
If the light on by itself, check the terminals you use for the push button.
For
The push button, one of the lane is linked together.
okay. Instead of me using it diagonally, I use it directly. Okay, so
Yeah.
let me change the polarity.
So it will on by itself.
Okay.
Hello. So are we there? Can we proceed? People don't like talking. No.
Yes, sir.
I want to hear from you. What have you been able to do?
So we wanted us to do another thing. I
Have you
thought
been able
what
to do
we've
this
done.
now?
Please, sir.
I gave you the chance to do this one yourself.
Yes, that is what I have also done. I was finding it difficult because as I switch on the simulation, the switch, as I started the simulation, the light on by itself. So I asked off, and I was told to change the polarity of the switch. So I've changed it and it's working now.
I asked you to change the polarity of the LED or the battery.
Yes, it was from the switch. Yes. Instead of me connecting it diagonally, I connected it straight in a line.
Yes, the switch. You see, this part is connected as one. And this part is connected as one. So when you bring it here, it's like short circuit.
Okay.
That Has any other person been able to do this?
Yes, sir. I finished my one. It's working.
This one. So we are going to continue, okay? So this what you have done right now is a verification of Ohm's law. Now we are going to play with it a little. This time we are going to take a potentiometer. This potentiometer is a variable resistor. We are going to remove this switch and take a slide switch, sorry. So we fix this one. Then we are going to change the resistor. And then we are going to put the variable resistor. We'll see what will happen very soon. You connect it like this. Then we connect it like this. This terminal 1, this terminal 2, this is a common. So you can't take from terminal 1 and terminal 2 and to wait for you need a common. So you take a common, bring it here, turn it, and then straight we connect it here. Okay. Look at what happened now. You see the potentiometer? Let's now simulate, start simulation. It's on, right? You see that the LED is glowing small, right? Now we turn this potentiometer, look at that. It's not working. It's on, but it's not varying. The reason is that I deliberately did that for you to see something. This middle is the determinant of varying the potentiometer. So you see it is written wiper, like the way the car windscreen wipes. So to be changing from a low potential to a high potential, or from a high potential to a low potential, by increasing the resistance and reducing the resistance. So this one needs to be connected to this place, needs to be connected to either here or here. I'm simulating, sorry. So I need to stop the simulation first before. So I click and then I can choose to join it to this. So it's joined now. Now let's do the simulation again. Look at what happens. You see it's burning. I've sent the potentiometer to the highest. So bring it down. You see it's gone down. It's gone down, 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 and down. So it comes to the list. You may not appreciate this one because it is light. You can't see well. You see, watch you. You see, it's increasing. You see now it's burning. That's the highest. It will burn. So we can do the same thing by putting let's use another load. Let's put another load there. We can put a motor, a DC motor. We stop the simulation and pick a DC motor. DC motor. See, it has appeared. DC motor. I pick it. So this is it. Now I bring a DC motor here. Then I'll connect to it. So from here, I'll connect to this one. And from here, I'll connect to this one as well. So I'm connected now. Let's see what happens. Start the simulation. You see how the motor is turning. But are you realizing that the LED is not glowing again? Watch this. So let's come to the maximum. You see LED is now glowing.
Hello, sir.
Yes.
Please connect it. The line. When I get to the joint and I have to release it. Breaking is becoming a problem. I don't know what to do to break it.
Okay, so send it to the extreme. Send it to the terminal of the component. Don't Tinkercad will not allow you to break in the middle. Had it been keycard or multisim, you would have gotten the opportunity to join on the wire. Tinkercad make it look like the wire is insulated. It's insulated. It's not a bare wire.
Okay.
So you have to go to the terminal of the component to join.
Okay.
So even my own, this one that I did here, I went to the terminal to join. It didn't join.
Okay. Okay.
So as of now, I'm running the motor, but the LED is not glowing. Why do you think the LED is not glowing? Your own way, why is the LED not glowing? I'm increasing the resistance again. Look. See now it's going slowly. You see. Now it's very slow. You see that? When I reduce the volume. If I reduce the resistance, look at that. I'm reducing the resistance. See, it's going faster. See, now it's enough to burn the LED, so the LED will burn. Okay. So we can create our home wiring. We can create our home wiring. We can use an AC circuit. So let's stop the simulation and design an AC circuit, an alternating current circuit. Something like a home wiring. Let's see what happens using Tinker card. Anyway, we could have done the whole thing on a breadboard. We can create the whole thing on a breadboard if we choose a breadboard. Okay, so in trying to do that, let's look for AC source. AC. Or let's look at function generator. So we have a function generator here. The function generator. So this is going to supply an AC waveform. Okay, so this is the same as a generator. Let's say a generator or a kosombo. So the specification. See, so let's call it AC source. We choose to AC source. Oh, what's happening? So if anything happens like this, just go to undo. Let me select again. Then it's here. The name of component A C source. Right, frequency. You see that? So frequency will be 50 hertz, right? 50 hertz. Amplitude. Yes, what's the amplitude? What's the amplitude?
63.
63.
Uh,
You say 63. I've written 63. And why we should get ACU. Okay, so the waveform should be sine wave. The voltage, I wanted the voltage to be 250, not 2.5, but it should have been AC, not DC.
outside. So is this okay, it's DC.
This is DC. I wanted an AC. This direct current. I wanted to take real electrical components and fix them so that we simulate and see. Yes, I mean,
Yes, sir.
had it been like this, we have the luxury to switch between DC and AC. It would have been perfect. Let me see. If not, let me try and see if I'll get another device. Let me search and see. Oh, I need more generators. So let me see. Generator. There's only one. There's only one. This, you see, not all the softwares have everything we need. That's why we need to learn different types of softwares, because you are not using paid version. If you use paid version, it will give you all the resources. Because we are using uh, student subscription and we don't pay for it, so we are limited. Okay, so the generator. They don't have it. So you don't have any choice than to use the DC one. So we take this one like that.
So please type power supply. Let's see.
Power supply will give us regulated power supply, which is DC. It's the same thing here. If you get, let me show you power supply.
Yeah. Yeah, power supply down.
See, this is the same thing. See, let me choose that one.
But if you click on it, okay. So
Let me
we are
delete this
getting.
one. Let me delete this one.
Mm.
Probably I'll get voltage. Voltage. Let me see. AC 240 and then current 15 amps. 15 amps. And
I think the voltage you can put 240 only. It will.
240. Okay. Okay. So let's try this one and see. What they have written here, I don't see it. Aha. Oh no. VC. It's up to 30 volts. Current is up to it won't help us.
5 amps.
5 amps. And the current is, the voltage is 30 volts, which is DC. It's not easy.
So please on it. Let's see.
Unless I start simulation. See that?
About 240 will come.
Well, okay. So the current,
No load.
yes, yeah, of course, it's true. No load. But the problem is that, okay, let's put in something and see. Bob. Light bulb, eh? Okay, so let's simulate this one and see. 40 volts to burn. So that means that we can do AC simulation. Okay. So now we have to reduce the voltage.
But can we increase the voltage of the bulb?
No, let's rather, we shouldn't reduce the voltage. We should rather reduce the current. Of course, it's AC. If it's AC, you see that? Let's use 2 amps. Still burning.
Maybe you can increase the voltage for the light bulb, the voltage and the current.
So be patient.
Okay, 100
See
ammeter.
You see it has reduced.
Yes.
You see it's working now. So it has shifted to 4 volts, 4.8 volts. And then the current is 100 milliamps. But then let's go and check the rating of this one. Let's stop the simulation and check the rating. It's just a name. You see that? So it assumes it's a light bulb, and then the light bulb has 12 volts,
12 volts.
12 volts,
3 watts.
3 watts. You see, so it is not, that is specification. So it could be like a solar bulb. You see that? So we have to manipulate the regulator to give us what this one requires. You see. Let's see if we can get electric fan. No, no, no. What else? So it means that we cannot do a pure AC analysis here. You understand it? we can only get a DC equivalence of the AC. We cannot do pure AC analysis. So let's further do some experiments and see what happens here. Let's get a capacitor and an inductor and connect them and see what will happen. Okay, so capacitor, you have this capacitor. You take a polarized capacitor. I don't want this thing to be like this. Why is it displaying like that? So we get this capacitor. Then let's get inductor. So get an inductor. Okay. So let's rotate the inductor and let's rotate the capacitor. Now we are going to join the inductor and then the capacitor together. And then this. And we take this. You see negative side of the inductor, of the capacitor. Remember, inductor has not got polarity. Okay. So this one will go, and this one will take it like this. Okay, having gotten this, now what I'm going to use to do the measurement, right? Let's get a frequency counter. Okay, a frequency counter. How will I call a frequency counter? Okay, let me see. Yes, think it's the counter. Now it's giving an IC. Okay, so because we are not having, let's take an oscilloscope. We take an oscilloscope. Hey, it has collected everything. Okay, so we place this on here. And we take this pen. Are you following?
Yes, sir.
Okay, so let's see what happens between a capacitor and an inductor when they are connected in parallel and supplying voltage between them. So let's now consider the values of the capacitor. So the value here is 1 microfarad. Let's make it 10 microfarad. And it's operating at 16 volts, which is too small because the voltage can go up to the source voltage can go up to 30 volts. So let's make it 150 volts. All right, so the inductor 2 is 10 Henry. Let's make it 50 Henry. A micro Henry. Oh, micro Henry. Let's go to milli Henry. Micro is too small. Milli Henry. Okay, it's not applicable. It was 1, eh? Let's keep it there. Okay, so let's simulate it and see. That's simulation. We're supposed to get but guys, do you remember what you said about capacitors and inductors? Remember? Do you
Yes,
remember?
sir.
What do you remember?
So capacitors store electric electrical energy in form of magnetic charge.
In form of what?
Charges.
Uh-huh. And inductors store in what? Electromagnetic.
Magnetic field.
Yes, but that's not what I'm looking for. They do the transformation using what? A changing current. Remember, a changing current and a changing voltage.
Yes, sir.
If the voltage is constant, or if the current is constant, to be seen as a short circuit for an inductor and an open circuit for a capacitor. So if the current is constant, which means if it is DC, the capacitor will not charge. To be seen as open circuit. So that's why there's no change in potential over here. I mean, there's no change in potential here. So we cannot record anything. You understand? There's nothing vibrating here. So we can't record anything. It's open circuit. You see, practical, so you can't lie. That's the thing. You see, if I was just lying in the previous lecture, if I was just talking without knowing what I was saying, this is the place it would have exposed me. You understand it? In practicals, practical lesson is different from theoretical lesson. You can get a lesson, the lecture will talk. When it gets to the actual implementation, you'll be baffled. You won't understand why it's not working. Right now, let's do another thing and you see and appreciate what we are talking about. So let's do away with this one. So let's do away with the supply. Then we'll take, let's go and take a different circuit like transmitter. Okay, so let me create a circuit right now and let's see something. BJT transistor. So let me take a transistor. NPN. Okay, so NPN transistor. I'm going to create a circuit right now. A capacitor. It's a long story. Oh, what I wanted to do, if I started to be, it will take me a long time to do. That's why. Anyway, let me just do it at once. So emitter is collector. So let's just construct a simple common emitter amplifier. Okay, common emitter amplifier. Then we feed the output to the oscilloscope. Then you see the oscilloscope be functioning. That's what I want to achieve. So that you see that the oscilloscope receives sinusoidal waveforms. Okay. So we feed the base with this. Then we feed the then emitter. Collector will take collector resistor. Collector takes collector resistor. Then there must be biasing resistors. So this resistor, 1, resistor 2. So this resistor will join to the base. And it will come here. And this will now go to emitter. This will go to ground. Emitter will also go there. Okay. Then the base will link with the collector. Oh, this is wrong. It's rather this will come. Let's delete this one. It's rather the emitter. The output to be taken from the collector. So let's leave this one. Output will be taken from collector. So let's join this. Rather to this. Okay. Then the emitter will have emitter resistor.
Hello, sir. So please, what are we building?
So we are building an amplifier circuit right now.
Okay.
This amplifier
Now,
circuit. Mhm.
the one they use for the musical and
Yes, we have
something for
so many
speaking.
types of amplifier circuits. We have the uh, let's say RF amplifiers. We have audio frequency amplifiers. So we
Okay.
are just trying to generate an AC wave. That's what they're doing. And we use amplifiers to generate a AC wave. Okay. So emitter will take a resistor. And then a capacitor. Then we mirror it. So we join this and this and that, and then to go to emitter. So emitter will come, join here. Then this also join to this. And this now join to this. Then the two of them like this. Good. So now the collector will be the output signal. Okay. Meanwhile, the collector also receive power from the source. So this way we are going to connect our batteries to this one. Then the output, now we are going to feed the output to the resonator. The resonator we're trying to create the first time that didn't work. So we now bring it here. So this is the resonator. Then we bring this to create the tank circuit. We call it tank circuit. Okay. So just observe what will happen. We join this to this directly. And then we join this. And we take this one. Why did I bring this one here? So this is supposed to be here. This is where we are going to put our output. So we are coming to finish the connection. So you have to bring a function generator to generate a function, which is AC function. So function generator. Okay. So the function generator is coming to generate sine wave, a DC offset of 2.5 volts, amplitude change in the waves should be, if you are coming to mimic like a human voice, that's what we are trying to do here. So let's say 5 amplitude is okay. Then the frequency is 1000 hertz. So this is too high for human voice. This is high for human voice. So let's stick to, let's say 10 hertz. 10 hertz. All right. So it's supposed to be this one. Now let's see what happens. We feed the input to the coupling capacitor. All right. Then we feed the neutral to, let's say, this resistor. This is the output, so neutral line. Now we will go for a battery. 9-volt battery. We take the 9-volt battery. We put it here. All right. Now let's mirror the battery. Okay. So the positive goes straight to the collector. All right. Where's the collector leg? So positive here. Then the negative will now move to the neutral line. Here's the neutral line. So let's put it here. All right, so let's simulate and see. The capacitors are bent, but you see the waveform. It means I didn't choose the values of the capacitor well. So we have to stop the simulation and get the values of the capacitor. So let's make it 10. Then microfarad. Also 10 microfarad and see what will happen. Still, it's burning. They're supposed to be producing a square wave. So it's 100 divisions per time. We need to reduce it per milliseconds. So let's make it 1 division per millisecond. Is too low. So I'm expecting a sine wave, but I'm not getting a pure sine wave because the circuit itself was just a mind thought circuit. It's not a circuit that has been carefully designed. You understand? But still, I've achieved my goal by producing a sine wave, by producing a waveform. Okay, you see the input waveform is supposed to be sine wave, and we are expected to get a sine wave output. We are getting a square wave output because of the kind of circuit components are used, and then the values are used are not a calculated value. It's just an arbitrarily selected value. So that's why it is happening like that. Please, have you understood what I've done? Hello?
Hello, sir.
If are you there at all?
Yes, sir, we are here.
You do I one day I'll put an assignment there and keep quiet and be looking at you. When I ask you a question, nobody's talking.
So please, we are here.
Okay, so where we are now, I'll stop sharing my screen, then you all show your face so that you know we are all the same page. If you don't show your face, it means that you are not participating. Yes, starting from the class rep, Kingsley.
Hello, sir.
Okay, you have seen you. Then
Okay.
Bernard.
Show your face.
Philip.
Please, my camera is not working.
Sarat. Okay, so if we are all there, Raymond.
Please, my own is working now.
Then who is this? ICDE.
So he's the host. He's the one doing the recording.
Is he a student?
No, sir.
It's from the no, not a student. From the office, the ICD office.
Okay. Anyway, that's fine. All right, so with this, we have been able to use the simulator to verify the construction of electrical circuit. All right. We have also understood that we can use the simulator to simulate electronic circuit. With electronic circuit, we'll be using the breadboard, okay, which we'll be doing very soon. We have also understood that you can use the simulator for code blocks and also for 3D modeling. Okay, so the assignment you are going to take today is you are going to use the simulator to simulate a simple circuit on Ohm's law. Okay, so you are going to design and implement that with the simulator, and that will be taken next week when we meet again. Okay, when are we supposed to end the class?
But please, 45.
What 45?
Please give me the time or the date.
The time.
3:45.
Or then we still have some
Yeah, we have some minutes more.
12 minutes, right?
Yeah.
Mm. So I would like to use this period or this time to find out about your perception about the simulation.
Okay, so for me, I was thinking if we will get pure electrical simulator because it is electrical electronics. Now that we have the electronics, you have the electronics simulation software. If you you can get pure electrical simulation software so that you blend the pure electrical side and the electronic side.
Okay, so this is good. I asked this question. Now, the most of the electrical simulators are paid softwares. Okay, the ones that are free, well, we can also get access to those ones. Like I said, we'll be using AutoCAD, right? But I'm introducing to these ones because we are going to use these ones to solve a lot of problems relating to circuit theory. Okay, and then those ones too, we will not be able to design and construct circuit that we are going to print. Okay, so I want to introduce you to Autodex, which has the electrical simulators. Okay, which is also used for simulating electrical circuits. All right. Hello.
Hello, sir.
Have I answered your question?
It was Philip who asked the questions.
Yeah, Philip, have I answered your question?
Yes, of course.
Now, I also want to ask you, do you have any simulator that you're expecting us to use?
Uh I think we have some simple one that maybe
Like which
that
one?
we can is uh um it's called cat sim. Cat sim.
Okay, CAD-SIM.
Yeah. Let me see. I think I have used some before. Let me see so that I will project my screen so you can see.
Okay,
Hello, sir.
yes,
So, please, at the end of the day, are we going to use it in? Are we going to use it for electrical drawing, like plan drawing and reading of plans and other things?
yes, we are going to do that.
Oh, okay.
Okay,
Okay. Okay, sir.
you see, this is the first time we are using, with me actually, we are using simulation softwares. They come in various
Yes.
grades. Okay, and there are
Okay.
some, if you are introduced to right now, like for example, if I start the Autodex with you right now, you may be facing some challenges. And then some are also tailored to specific functions. Like though Tinkercad has functionalities for, I mean, 3D modeling, it's not a best tool for modeling three-dimensional figure. Though it has that function, it's not the best. It cannot take accurate, precise measurements for printing. It's not the best. We have some for that. Something like KiCad is best for drawing PCB, something like Tinker card. What do you call it? Every circuit. Okay, I've seen this. I've seen this.
Yeah, someone was showing me this long ago, but
I've seen this. So we can use AutoCAD. I mean, uh, Autodex to do the same thing. Okay.
uh, stop sharing, stop sharing, stop.
So this is CAD what?
CAD sim.
CAD eSIM.
Yes, sir.
Hmm. So it's also good. Okay. But this one, you see how it is. This, can you bring it back? Project it again, okay.
Yes, sir. So this one, when you simulate and the motor is running, you see the sign. You only see the sign if it is going reverse or forward. You just see
Don't
the
see
sign.
it as in rotation, right?
Yeah, when you start the simulation, it is running. You see that you see the sign like running, and it
I
will
mean,
show direction whether it
going
is
clock.
running forward.
You see it going clockwise or anti-clockwise.
Yeah, yes, yes.
Okay. So if I place a lamp, will I see the lamp glowing?
So this one is purposely for electrical motor control and other things.
Uh-huh.
You can for the data, direct online, and all the electrical
Yes. So can I put
electrical.
in like a lamp
Yes, yes.
and the lamp will
We have
glow?
Yeah, we have lamp that maybe if the motor is running, it will on, and when like phase failure and all those things.
All right, sure.
Before, but they were introducing Arduino inside.
Hmm.
They were introducing Arduino, but I don't know inside much. So
So we can do we can do electrical electronics.
yeah, yes, yes, yes. Okay, so 3D we have this one. This one
Okay.
is for Arduino.
This a relay.
Yeah,
This a
and we
relay.
have
So with this one, we can do electrical electronics control.
yeah, yes, yes.
Mhm. Okay, so we can equally use this one, okay, in place of the Autodex. All right.
Yeah, yeah. If you don't, because of this one is very light. It's very light. Like
It's
very,
very light.
very.
The Autodex is too heavy. Autodex is too heavy. Okay. So it's okay. It's okay. I've seen it. So thank you. We can still use this one. Philip, thank you very much.
Okay. Sir.
So we have gotten one in addition. That means that we are going to do a lot. Okay. God willing, next week. Let me also tell you, so you start doing this at once. When you go, I mean, you can use uh, every circuit. It's a mobile app. You can use it on your phone. Every circuit will help you see the direction of flow of current. Okay. You see the direction of flow of current, how much current flows into a junction. Where the current splits at a junction, you will see with regards to it's very good. With regards to the resistance, you see how much current will flow through a resistance of a resistor of higher resistance and a resistor of lower resistance. Uh, Solid state components like capacitors charging and discharging, you will see all vividly. So it's like you are seeing inside the circuit element. That's what every circuit does. So you see everything and understand it better. So with a combination of Tinkercad, every circuit, KiCad, and then the one you just brought, which is what? CAD eSIM, right? And then what again? Multi-SIM. We are good to go. Okay. I would like us to simulate some circuits and then we will print them out on printed circuit board. And then we solder the components based on the soldering we did at the lab, or the day we meet at the lab, then we do the soldering. Okay. Is there any other question? Is there another question?
I think there is no other question.
All right, so we can end it here. Okay.
Okay. Thank you, sir.
All the best. Then.
Bye.
Bye.
Hello.
Hi.
How far?
The
You
genome
close?
dama.
Okay. So see you in the next lectures. Three
3:45 or you what?
3:45.
Ah,
The time is up, oh. Charlie.
No, he said
Oh,
we will be
Presto.
meeting. No, I say 4. Or no lecture, I say 4. Say our class.
Ah,
No.
C4, yeah, C4.
okay. Sorry, you don't kiss me for